For the 8C video 2, example 7, we're going to evaluate p of negative 2 for p of x is x to the third plus 5x squared minus 4x minus 20. So we're going to take negative 2 and plug it in and simplify it. So negative 2 to the third plus 5 times negative 2 squared minus 4 times negative 2 minus 20. So that's negative 8. That's 4 times 5. That's going to be plus 20 plus 8 and minus 20. Because you can see it, plus 20 minus 28, negative 8. This is going to come out to be 0. So when we evaluate, when we plugged it in, we get a 0. So according to the factor theorem, what does this tell us? It tells us that if we plug negative 2 in and get 0, that x plus 2 is a factor. And that the remainder, when I divide by that, it's going to be 0. So this says, okay, so this is kind of like a star. We're going to factor now. We're going to factor, knowing one of the factors, we're going to try and find the other factors. So if x plus 2 is a factor, we're going to divide this into the polynomial and see what's left over. So I'm going to have negative 2, and it's going to go into, I have a 1, 5, negative 4, and negative 20. So draw my line, that's going to be 1, negative 2, 3, negative 6, negative 10, 20, and this adds up to be 0. So this is no surprise. We have a remainder of 0. So when I divided x plus 2, I get this answer. So remember that if we start with an x to the third, it's going to drop down to x to the second. So I have x to the second plus 3x minus 10 is my remaining polynomial. So right now this really says this times x plus 2 gives me that polynomial. All right, so now what we want to do is factor this. So because we can factor it, two numbers that multiply to be negative 10 and add to be 3 would be 5 and 2. So we're going to factor this, and it's going to factor into x plus 5, x minus 2, and then we also had the x plus 2 that came from this here, here, here. So what are the zeros of p of x? Well, the zeros are what makes these equal to 0. So if I set this equal to 0, so x plus 5 would give me negative 5, x minus 2 would give me positive 2, and x plus 2 would give me negative 2. So those are my zeros. What does this tell us about the graph? Remember from last set of notes? That means that we have x-intercepts at negative 5, 2, and negative 2. So if we know one of the factors of a polynomial, like we did in the last example, we can use synthetic division to find the other factor. And if this factor happens to be quadratic, which it was, we can find the solutions using the method you preferred. We just factored. We could use complete the square, if that's your favorite. And we could also use the quadratic formula to find the other two factors. All right, so let's take a look and ignore this stop. I don't know why that's there. It just happened. Example 8. Use synthetic division to show that the number given to the right, so this one right here, is a solution of the equation. So to show it, if I'm going to use synthetic division, that means that I want the remainder to be 0. So if 3 is a solution, that's going to mean that x minus 3 is a factor. And then we're going to get a remainder of 0 here. So let's do that. So I'm going to 3. So if 3 is a solution, the 3 is going to, notice this goes in the box. I don't change the sign there. The sign only changes when I put it with the x. So I have 3, and then I'm going to have 1, negative 5, negative 29, 105. Then we'll do our division. 1, 3, negative 2, negative 6, negative 35, negative 105. And I get a remainder of 0. So that means that we have x squared minus 2x minus 35 left over as our factor. So at this point, it factors, bring this down, x minus 3 right there. All right, so can I factor this? Ooh, 7 and 5. Yeah, that'll factor. So that's going to be x minus 7, x plus 5, and then x minus 3. So my question asked, it says to solve it. And when I go to solve, I want to find the zeros. So solve means find. The zeros are the solutions. So we want to know when it's equal to 0, that's going to give me a 7, a negative 5, and a 3 for my solutions. Oops. Guess I should show that. All right, so example B also has 3 as a solution. So we're going to check that out and do the synthetic division. So 1, negative 5, 5, 3. Draw the line 1, 3, negative 2, negative 6, negative 1, negative 3, 0. So that's going to leave me with x squared minus 2x minus 1 as that factor. And then this one gives me an x minus 3. Two numbers that multiply to be negative 1 and add to be negative 2, not happening. So that means that I can either complete the square, which I would prefer, or use the quadratic formula. And I know some of y'all use the complete the square, but many do the quadratic formula. So let's do that. So we're going to then find the solutions here. So x is going to be equal to 2 plus or minus the square root of 4 minus 4 times negative 1 all over 2. So that's going to be 2 plus or minus the square root of 4 plus 4, which is 8, over 2. So 2 plus or minus 2, radical 2 over 2. So 1 plus or minus the square root of 2. So that's 2 answers. So if I were to write my solutions would include the 3 from the very beginning. So my 3, it would be 1 plus the square root of 2, and 1 minus the square root of 2 would be my solutions. All right, so I'm going to stop and let you try this one right here. And we'll pick up in class and finish the rest of it in the following class.